Vectors in 3 dimensions. Basically, it's the same thing as vectors in 2 dimensions, only now we have the z coordinate. So we will have what's called an ordered triple. Okay. So if we have 2 points, P1 with x1, y1, and z1 as its ordered triple, and point 2 with x2, y2, and z2 as its ordered triple, the vector from P1 to P2, the ordered triple to represent this vector would be found by x2 minus, don't know what that triangle was all about, but that's craziness, will be found by doing x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. Ignore this triangle, it does not belong there. So if we have, and then of course the magnitude of the vector from P1 to P2 will be found by the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay, similar, just the same as the other types of vectors. So here we are going to write a vector. So here's example 1. We're going to write the ordered triple to represent the vector from A to B. Where A has coordinates -2, -5, 0, and B has coordinates 3, 1, 8. So, vector AB can be found by 3 minus -2, comma, 1 minus -5, comma, 8 minus 0. Vector notation, sorry. So we're going to make that plus a positive, make that plus a positive. And we're going to have the ordered triple to represent this vector is 5, 6, 8. Once you have the ordered triple, to find the magnitude, so that's the next thing we're going to do. The magnitude of vector AB is simply the square root of 5 squared plus 6 squared plus 8 squared, which is the square root of 25 plus 36 plus 64, square root of 125. Simplify that radical. It's going to be 5 times 25, or 5 times 5 there. So the magnitude of vector AB, for every pair you bring one out, it's going to be 5 radical 5, because this 5 is still in there. Okay? Excuse me. Example 2. Here we have 2 vectors. Here's vector V with ordered triple 1, 7, 1, and vector U with ordered triple -4, -2, -6. Okay, what are we going to do with this? Well, we're going to do some vector operations. We're going to find for vector V plus vector U. So just like with the last video, we're going to have 4 times 1, 7, 1, plus -4, -2, -6. And this is where we've got a scalar multiplication, so we're going to multiply each one of these components. So this would be 4 times 1 is 4, 7 times 4 is 28, and then 4 times 1 again is 4. And then we're going to add them to their corresponding components in the other vector. So it's going to be 4 plus -4, 28 plus -2, and 4 plus -6. Do that, we're going to end up with an ordered triple of 0, 26, -2. The last example we're going to get into here talks about unit vectors. Okay, so unit vectors. Recall that vector I is the horizontal, vector J is the vertical, and then our third dimension is going to be vector K. That's our coming up out of the page. Okay, your third dimension, that's your unit vector. So we've got I, J, and K. So example 3, we're going to write vector AB as an ordered triple and as the sum. Now, of course, point A has coordinates 5, 10, -3, and point B has coordinates -1, 4, -2. So, to write the ordered triple for vector AB, we're going to do -1 minus 5, 4 minus 10, -3 minus -2. Oh, sorry. Wrong order altogether. Shame on me. -2 minus -3. Make that plus the positive, of course. -1 minus 5, that's -6. 4 minus 10 is -6 again. And then that's going to be 1. There is your ordered triple. Once you have that, to make it a sum of unit vectors, it's pretty simple. Vector AB is going to be -6 times the horizontal vector, which is vector I, plus -6 times the vertical vector, which is vector J, plus the up out of the page vector, which is vector K. 1 times that, so I'm not going to write the 1. Let's pretty it up a little bit. -6I minus 6J plus K. There you go.